Okay, everybody, welcome to Math Decision Making for Life, quarter 4. The chapter we're going to start this quarter with is circumference, area, and volume. And on our first day of circumference, area, and volume, we're just going to do review of area and perimeter. So I'm hoping none of this is new information to you, but if it is, you're definitely going to need to know it eventually for when we get into the stuff we're going to get into. So starting out, review of area and perimeter. Perimeter is the boundary line forming the outside of a closed geometric figure. Calculating perimeter, or actually back to perimeter for a minute, it's just the distance around the outside of a figure. You're looking at the outside of a figure. Calculating perimeter, add all sides, and I'm going to put all in a box. If it's a rectangle, it has 4 sides, you add 4 sides. If it's a pentagon, it has 5 sides, you add 5 sides. Depending on whatever shape you're talking about, add up all of the sides. Moving on. Perimeter examples. A construction worker has 40 feet of caution tape. Is this enough tape to surround a rectangular region that is 120 inches long and 90 inches wide? So the first thing I'm going to look at here is the fact that he has 40 feet of caution tape. And then the next thing I'm going to look at is he has a rectangular region that is 120 inches by 90 inches. So keep in mind we're dealing with feet and inches. If we draw a picture of his region, said it was rectangular, it's 120 inches by 90 inches, and he has 40 feet of tape. Now, the first thing I'm going to do is I'm going to consider that we're dealing with inches and feet. If you take a look at a ruler, 1 foot equals 12 inches. So if I have 40 feet of caution tape, I'm going to take my 40, I'm going to multiply it by 12. Grab your calculator. If you don't have a calculator at home, that's okay. Just use your phone. 40 times 12 is 400 inches of tape. And actually, I take that back. 480 inches of tape. Okay. Now, we need to know if that's enough to go around this region. So we're going to find the perimeter. I'm going to take 120 plus 120. Keep in mind, if the top's 120, the bottom is also 120. And then I'm going to add 90 plus 90. Okay. Again, grab your calculator. 120 plus 120 plus 90 plus 90, which is going to get us 420 inches. So take a look. We need 420 inches. We have 480. Is this enough? Yes. And in fact, he has 60 extra inches of tape. And if we want to consider that back in feet, we could divide 60 by 12, which is going to get us 5 feet of extra tape. Moving on. Okay, a worker installs fencing around 2 rectangular properties. One is 99 feet long and 80 feet wide. The other is 95 feet long and 83 feet wide. Which property requires more fencing, and then how much more? So I'm going to draw my first property. Just for funsies, I'm going to call this property A. And they told us that one of them is 99 feet and 80 feet. So I'm going to call this 99 feet and 80 feet. Second property, 95 by 83. So again, just for funsies, I'm going to call this property B, and then I'm going to label it 95 feet and then 83 feet. They want to know which one requires more fencing. So again, they're talking about the distance around the outside. So we're going to find perimeter. 99 plus 99 plus 80 plus 80. Now, if you're thinking in your head, do I have to find it that way? No. If you're familiar with doing 99 times 2 plus 80 times 2, absolutely, that works. Do that. Okay, so when we add all that up, I got 358 feet of fencing. Next one. So for this one, 95 times 2, because you've got 95 on the top and 95 on the bottom, plus 83 times 2. Again, or you can revert back to 95 plus 95 plus 83 plus 83, which is going to get us 356 feet of fencing. If we compare the two, okay, which property requires more fencing? I'm going to say property A. And then it says, well, how much more? 2 feet more, because we're going from 356 to 358. Next one. A gardener wants to enclose the garden with fencing. The garden is in the shape of 2 rectangles. How much fencing does the gardener need? So first of all, I'm taking a look at this. I know that this is 8 yards. I know that this is 6 yards. I know that this is 10 yards. I know that this is 3 yards. What I don't know is I don't know how long this is. And I don't know how long this is. So we need to find that. I'm going to take a look at the vertical one. If I'm looking at the vertical one, do you notice that the entire vertical distance over here is 6 yards? And then this vertical distance is 3 yards. So if the whole thing is 6, and I'm just trying to get that upper piece right there, and the bottom part is 3, then you take your whole thing of 6 minus your bottom part of 3, which gives you 3 left over. So I know that piece right there is 3 yards. Okay, same thing with the horizontal. Whole horizontal, 10. Top horizontal, 8, which means there's a little bit over there, which is what I'm trying to find. So if I've got 8 and I'm trying to get to 10, well, I need 2 more. So I know that part's got to be 2. Now, if I want to know all of my fencing, I'm going to take my 8 plus 6 plus 10 plus 3 plus 2 plus 3, and I'm going to add those up, which is going to get me 32 yards of fencing.